I'm Ty, or Tyler. I'm the co-founder and CEO of Continue. I guess prior to this, a little bit of background about myself before I introduce Continue. Scott and I actually worked at Raza, which was the open source machine learning framework for chatbots. So we were quite early in comparison to ChatGPT, but we were really trying to bring machine learning to dialogue management. So we were the folks in 2020 fine-tuning GPT-3 to be a user simulator to talk to our supervised machine learning chatbot, because at the time, RLHF didn't exist, so you couldn't put a LLM in production because it would say very bad things. And so it's been super cool to watch the maturity of the space. And then now, as of June of last year, I ended up jumping and starting my own company called Continue, and I'm excited to tell you about it. So we'll jump into it. For some reason, okay, there we go. So yeah, at a high level, we're on a mission to make building software feel like making music. I promise that will be the most abstract thing of this talk. Everything else is going to be quite practical. And so what we're doing is we're building a modular open source GitHub Copilot alternative. And so you can think of it as a reusable set of components that enable you to create your own Copilot. So it's a VS Code extension, JetBrains extension at the moment, where you can entirely understand and see all of the code for both tab autocomplete, as well as kind of this sidebar experience where you can kind of highlight code. And we'll talk about kind of other features as well as we think about developer data. And developer data is probably kind of a new concept, development data, dev data, as we call it for many folks, because unlike kind of the black box alternatives, we don't vacuum up all of your data. Instead, we give you access to it. And by giving you access to it, you can actually use that to first understand your system, but then improve it. And so I want to kind of motivate the talk a little bit before we jump into how do you actually use your data, because it's important that you first believe you want to do that. And so the first question to ask is like, why do I want to make LLMs code like me and my team? And the basic premise that we start from is that when we think about what makes software development fun and worthwhile and why we do it is because of flow state, right? Where we're able to feel focused, feel productive, be creative, feel like we're actually contributing something. But the unfortunate reality, especially as software has become more complex, is that you often get disrupted and your flow state kind of goes away. It's hard to kind of remain in flow state. It's hard to continue in flow state. And like one great example is if you're kind of using a new technology or something you're unfamiliar with, right? The Google Stack Overflow experience where you have to like get out of your text editor or IDE and you have to search things. And so I think this is why so many of us are excited about software development copilots, because you can get help without having to really change the steps that you're already doing and don't kind of get distracted by going to the browser and discovering TikTok. And then the other thing that is not so great about these kind of copilot systems is they're often giving us bad and wrong suggestions, and that also disrupts flow state. So there's this great blog post, I highly recommend reading it, by Josh Collinsworth called "I Worry Our Copilot is Leaving Some Passengers Behind." And I think he creates a really great example of something that's kind of like a bad, wrong suggestion that like trips you up. So here he was like showing he wanted to add anchor tags to his personal blog, and he asked Copilot to help him with it, and Copilot suggested breaking out into JavaScript, which is very unfortunate because you can just very simply use the header tags that already come with HTML or anchor tags with HTML, and breaking out to JavaScript means you're overriding decades of kind of user experience on the web and accessibility stuff that we've done unnecessarily using JavaScript, and it likely is kind of the first step in a bad pattern that will then be propagated by these systems. And so we start with the premise of like, when you see something wrong, you should be able to do something about it. And that's kind of where we want to move the Copilot systems that we're using while coding. And so then the other thing is, okay, if you hopefully now agree with me that you actually want to improve the suggestions you get, you want to do that, what you need is development data. And so what is development data? In the world of at least Continue, dev data is kind of how you build software. So you can kind of think about it as all the different steps that you take in between Git commits, right? So there's lots of really rich data that has been used to train large language models today based on like the code base and also even versions of the code base over time. But there isn't a lot of data about what happens, right? What happened in order to get from one state to the next one. And so in Continue's case, when you use Continue, it creates a .continue directory and creates a dev data directory. And I'm just here listing all of that, where then every time you decide to hit tab or not hit tab, it actually drops that into a JSON line file and other kind of data. And it's actually just a byproduct of using LLMs. I think that's really important, where if you've ever experienced, especially in the supervised machine learning world, where you're trying to get people to annotate things or to do something that isn't part of their core job, they're unlikely to do it. But if it's in the process of you building software, that you're creating data and effectively giving really strong signals that could be used to improve the suggestions you get in the future, that's really magical. And so how to use your development data is really kind of 3 steps. Like the first thing is you actually need to start collecting it and looking at it. And then step 2 is to actually improve the compound AI system. And step 3 is to even improve the large language models using it. And so this is going to be preaching to the choir, right? But it really does start with you actually looking at it, especially if you're, like, say, on the platform development team at your organization, and you're looking at this data for all of your developers. It's important to understand how are they using the Copilot systems that you offer. And so in the case of Continue, I just printed out like the autocomplete JSON line file. I would probably recommend not looking at the data directly in the terminal, right? But after maybe you've extracted and loaded it and put it into a nice BI tool, which all of you kind of know a lot more about than me. But first, kind of really understand your data, your development data. And then the kind of easiest, the next thing to do is then actually improve the compound AI system. And so you might ask, like, what is a compound AI system? And this is where I'm hopefully going to rearrange your understanding of what GitHub Copilot is, right? So most of you might think of it as probably like GPT-4 and inside VS Code and JetBrains. But the reality is it's actually a system with about, depending on how you count, like 7 different components. It's 3 models. It's a chat model that's usually GPT-4. It's a tab autocomplete model, probably around 10 billion parameters, and then embeddings model, as well as kind of a context engine that runs on your local computer and figures out what tokens to give to the autocomplete model, a server-based context engine that figures out like what parts of your code base are relevant when you ask a question about your code base, and like a filtering engine where it makes sure you don't violate public code or use libraries that are unapproved. And so Berkeley Artificial Intelligence Research Lab created this awesome blog post in February about the shift from models to compound AI systems. And it's what they've kind of observed is even in like state-of-the-art research, we're moving more and more towards from like GPT-4 itself being state-of-the-art to GPT-4 plus some other components being the state-of-the-art, not just within software development, more broadly. So they're actually even going further than me and trying to pitch the idea that this year, by the end of the year, you're going to see people talking more about compound AI systems. So I'm kind of using this idea from them, but specifically in the world of software development, and it is a way of understanding what Copilot really is. And so the first thing to do when you're trying to improve the suggestions you get, right, is to make sure that everyone in your organization is actually using or is trained and successfully instructing the models. So like this is the example from John's blog post, right? So on the left, right, he was using the tab autocomplete GitHub Copilot, but he could have also used kind of the sidebar experience where you're chatting with it. And so if you just ask for like, give me a component that helps me generate footnotes on my personal blog, like you might get something that's a JavaScript suggestion. But if you learn to know that you don't want a suggestion like that, you can also just literally ask and say that part, but then add on like using anchor tags and nothing else, right? And that's a way to kind of guide the model. And so usually a great starting point, maybe this is also obvious, is to make sure that your organization, right, the engineers at your organization have kind of the basics of understanding of if you want the model to do specific things, you have to make sure to tell it to do that, right? But that's not also a great solution for kind of improving the suggestions you get, because if you have to give all of the detailed instructions of all the ways to do it to the model, you probably should just do it yourself. So this is the easiest one, but also kind of not necessarily the most powerful one. So the next thing you can do is to actually add instructions into the system message. So when you call the large language model, you can kind of give it instructions it should always follow. The problem here, right, is it's limited, but there's some value in it. So like here I was using DeepSeek Coder 33 billion with Continue, and I asked, how do I kill a process? And it just guessed, right, that I was using Linux in the left side because I had no system message. But on the right side, like I just made sure to add my operating system is Mac OS. And so when I just ask, how do I kill a process, it knows to respond and only tell me about Mac OS. So that actually can be quite powerful for things like your operating system that stay the same, even for like kind of patterns you're seeing in suggestions that you don't want and that they keep coming up, you can put in there. But like I mentioned, the system message is limited, and so you can't shove everything in there, and you're probably fighting a losing battle as well if you're trying to, every time you see something wrong with suggestion, add it to your system message. It's not the most scalable kind of approach. And so the next thing you can do is to automatically filter for obviously bad suggestions and ask for a new one automatically. And so this is actually how like GitHub Copilot's blocking of public code, that like any suggestions that match public code works. What they'll do is they'll ask the large language model to generate some code. They'll check it against their repo of public code that they've indexed. And if it matches, then they'll re-ask for another suggestion, and then check again. If it doesn't violate it, then they'll share it. And you can use the same idea for other things. So if you work at an org where there's certain libraries that are approved, if the model suggests using a library that's not approved, you can do that same thing where you check and make sure if the suggestion is using a library, then reprompt, and that is not approved, then reprompt. Similarly, like if you want it to pass linter or tests or different things, if you want to check it compiles, you can do all of that before actually providing the suggestion to the user. Check. Once again, this is similar to the system message, probably in the long run a losing battle if you're now building a rules engine to basically make sure that suggestions are good. So the most powerful thing you can probably do, or second most powerful thing you can do, in my opinion, of improving the entire AI compound system without talking about particularly the models, are building your own vector DB and indexing your code base and really data from your software development lifecycle. So we have organizations that are bringing in their Jira tickets and their GitLab MRs and kind of more and more their database tables, all of those kinds of things. And so in Continue, right, you have like a @code base where you can ask a question about the code base, and it will use a local context engine that we provide, but also you can plug in some community-created context providers where you can add a particular Jira ticket. I believe that was contributed by one of our users, and you can even create custom ones. So if there are certain kind of data sources in your org, one that was really cool that came in recently was they wanted to get SQL queries generated for their databases, and so someone created like a Postgres context provider where you can add that particular database and then select the table you want and then say, generate me a query for this table, and it's going to be far more likely to be closer to what query you want than if you didn't give it the context of the table. But you also don't want to have to like go log into that database and copy and paste that. And so we're trying to really simplify kind of the developer ergonomics around kind of bringing in the right context. So this can be really powerful, especially for like when you're using like a new framework or library that was created after the model was trained, right? So we have like a @docs context provider where you can put in a link for that docs page, and then it will go and grab that docs. And that same thing can be for your internal documentation. If you have it in Confluence, right, the same thing can happen. And so this can be really powerful because if you give that context that the model really needs, it can do quite a good job of making sure to suggest things. And then I would say the most powerful thing, which unfortunately if you're using a black box kind of Copilot system that doesn't tell you what models they use, doesn't give you the opportunity to swap out models, it's not available to you, but if you do use a system that allows it, is really kind of just figuring out which models work best for the situation. So today, there's like 2 main models, but over time, I think they're going to become more specialized. The systems are going to use more and more models. And so the 2 models that are used today are kind of the chat model, so it's kind of like your ChatGPT experience. Those are generally like 30 billion plus parameters, so you generally need to run it on a server unless you have a really, really beefy laptop. It's probably too big. And for there, you're okay with some latency, so you just aim for the highest quality responses. And so examples are GPT-4 and Claude 3 if you're willing and able to use closed source providers, while DeepSeek Coder 33 billion, Llama 70B, as well as like yesterday, I think Databricks, while we were all here, dropped DBRX, which apparently beats like DeepSeek Coder 33 billion and Llama 70B. And so that's also a nice aspect about being able to choose which models, because there's so many new models coming out that you kind of want to be able to try and change. And what suggestions you get are going to be really impacted by what model. And then on the tab autocomplete side, the really interesting thing is what we've found, everyone who's building this space, all of the models are between 1 and 15 billion parameters, and that like using GPT-4 actually results in less quality responses because it's not as specialized and trained particularly for kind of auto-completing code. And also it's too slow because you need to respond to the user within 500 milliseconds. It is also quite expensive. And so here the tab model is is generally in the 1 to 15 billion parameter range because of the quality and latency trade-offs. And so what we're seeing as a result is if you have a MacBook today, you can actually run these models locally, which means you don't have to go to the server and come back, right? You don't have to pay any money because you're running and using your own compute. So maybe one of my not so hot takes is that I think in 5 years, like similar to spell checker, like all the tab autocomplete workloads are going to move to your local computer, assuming kind of VRAM and GPUs come to the local computers like NVIDIA and Intel and AMD and all these folks believe are going to be selling laptops for that. And so examples are like the original Codex model, StarCoder 2 from Hugging Face is open source, Replit code, also open source. And so once you've kind of really instrumented your system, you've tried to just, I would say, do some of the easier things, right? You've now set yourself up where you've collected the data you need to actually fine-tune, do domain adaptive continued pre-training or pre-train from scratch. And so we'll kind of walk through those. These are going to be the most powerful ways to make the models code like you and your team. And so the first thing to kind of like think about is, I think, let's step back and say, like, what really is the ideal training data for a large language model? Like today, it's been mostly trained on the internet. It's been trained on public repos on GitHub. But I think Andrej Karpathy does a good job of kind of really describing it, right? He says the ideal training data for an LLM is not what you wrote. It's the full sequence of your internal thoughts and all the individual edits while you wrote it. But you make do with what there is, right? And so a lot of like us training on the internet is just because it's very open and available, right? But in reality, if we somehow had access to the internal monologue in our heads and actions we took, that would actually be very powerful. And so the interesting thing that if once you kind of realize this is that if you're using LLMs while building software, that's actually pretty close to the ideal data that's just being generated as a byproduct of using LLMs while you use it, right? So there's kind of three things that I think we've identified at least that development data shows, which is like pretty close to that internal monologue and the steps you take. You're starting to reveal more and more of the step-by-step process you take while building software. Like, do you tab or do you not tab? After you've done some edits here, do you ask questions of the in the sidebar, right? And so you're starting to reveal a lot more, which previously like was not captured at all. Similarly, like the entire kind of task of using LLMs is often like figuring out what is the right context to give to the model, and that once again is really powerful data that kind of reveals kind of why you're doing certain things. And the last part is maybe the most fraught, at least in the case of using LLMs for software development, of like what is the reasoning? Why did you take these steps and not other steps? But some of that can be revealed based on like what questions you ask, right, and how you go about it. And so if you're not believing me in this idea, if you want to hear it in a different way, Google is actually, as of last year, they published this piece and going down this direction where they talk about how like software is not created in one dramatic step, right? Instead, there's a lot of different tools we use, a lot of different pieces we use, and if you actually capture those sequences of things, you can actually train better and better models. And so they created the dynamic integrated developer activity, and they're using this in production with the development teams within Google. And so we're not Google, or most of us, I assume, don't work at Google. But if you use Continue, what you'll be able to do is actually start to get some development data that is helpful for improving your models directly. And so like every time you tab or don't tab, those accepted, rejected are great data that signals like how the model should suggest in the future. We have this idea of like slash commands where you can highlight some code, do slash edit, have a request for an edit, and then it puts it into the IDE and the text editor directly for you. And you either accept or reject that. When you ask a question, it will give you some code, and you can click apply this code, right? There's also like you can check, okay, after I accepted this code, did it remain there unedited for a minute, for 1 hour, like 1 hour, 1 day later? Those are kind of signals where you can see, okay, if the suggestion was to do it one way, right, and you accepted it, did you actually kind of tweak it or not? And then that tweak can be used as signal as well. The results of RAG, right? So talking about like what kind of context is actually pulled in. Did the model actually use that? And so some kind of real world examples of kind of fine-tuning. Here I'm kind of giving a very high level heuristics of what you kind of need to be able to do it. These are going to get progressively more difficult, more expensive as we go into the different ways you can improve. The most obvious and easiest one is fine-tuning of models. So let's take the tab autocomplete model. DLT Hub data load tool. If you've come across these folks, he's here today. Adrian's actually here in the front. They actually fine-tuned StarCoder 2 on their code base, their docs, and then also accepted autocomplete data. And so for fine-tuning, you're going to also often want like domain-specific instructions for tab autocomplete. Basically, all day, every day, people are doing a kind of annotation, right? And all of those accepted things can be ELT'd. So if every developer at your org is dropping data into JSON line files on their computer, you can set up every day, you load that data into a central place, and now you have all of the accepted and rejected suggestions for the tab autocomplete model. You can then use that. And so they were able to teach their StarCoder 2 model, right, to go from, just doing a generic way of loading resources to the DLT way of loading resources. So you can kind of see a very clear example of after fine-tuning, they did it. Fine-tuning, depending on kind of the size of your data set, is going to be probably on the order of magnitude of hundreds of GPU hours. And similarly, GigaML is looking into this direction. They're really excited about the possibility of developers in open source donating their data and then actually being able to improve models in aggregate across open source developers. The next step is, if you really want to get models to code like you, is to do domain adaptive continued pre-training to improve open source LLMs. So generally, you're going to need probably billions of tokens of relevant company data. So depending on your org size and how long you've been around, you may or may not have that, specifically for software development. And it's likely on the order of magnitude of thousands of GPU hours. So far, it's been largely the big players in AI. So NVIDIA and Meta started with Llama 2, and then they took billions of token data. In the case of NVIDIA, it was about chip design. And then they continued to pre-train the model and managed to create a software development system that helps with chip design, like software development around chip design in the way that NVIDIA does it. Similarly, like the creation of CodeLlama was using domain adaptive continued pre-training. They started with the Llama 2 model, which is a generic model kind of closer to a GPT-4, and then they took, in the case of the 7, 14, and 34 billion CodeLlama models, they took 500 billion tokens and then continued training Llama 2, 500 billion tokens around just like code data in general, and created CodeLlama. They then took, I think, another 200 billion tokens and created CodeLlama Python, right? And then they also, I think, created a 70 billion with 1 trillion tokens. So this is like starting to become more available. I think this will kind of be the next step as you start to really get value out of models for software development. We're going to move from not just fine-tuning to doing domain adaptive pre-training is kind of the next step we're moving towards. And then the one that I think we'll ultimately get to, but is really expensive and difficult today, is actually pre-training models from scratch. And so you're going to likely need trillions of internet data tokens, the billions of company data tokens, and likely millions of GPU hours. And so I think this will likely be out of reach for many organizations anytime soon. But the kind of cool thing that's beginning to emerge is kind of this idea of a foundry where OpenAI and Mosaic together are actually willing to train custom models for you, where you bring the data. So OpenAI has a program. It starts at $2 to $3 million, so it's not cheap, but they'll actually train you your own custom GPT-4, where you could bring your billions of software development related tokens in your organization, combine it with whatever they train on GPT-4, and then the suggestions and the ideas and the completions you'll get from your custom GPT-4 will be that much better. Similarly, Mosaic worked with Replit to create their own tab autocomplete model. So when it's a much smaller model, if it's 1 to 15 billion parameters, like I think that's far more in reach, and together as well as offering it. And so just kind of in summary, the 3 steps that I really see to using your development data is to collect it first and look at it, kind of improve the compound AI system because it doesn't involve a lot of training or fine-tuning of models, which is expensive and slow and timely. And then as you start to really want to optimize and customize your system, kind of moving in and learning how to use your data for fine-tuning, domain adaptive continued pre-training, and pre-training will be key. And so in summary, if you actually collect your data and you use it, you can automate a lot more in your software development system. And so, I mean, maybe today you just use tab autocomplete in your org, but if you're starting to collect this data, you can do things like what Meta did, where they actually were able to generate unit tests at scale for Instagram Reels and a number of things, so that their developers don't have to spend as much time on unit tests. Similarly, like Uber, right, has decided to not use GitHub Copilot and even created their own, using CodeLlama, created their own RAG for their code bases. And so what we're starting to see is organizations who've really adopted and are loving kind of GitHub Copilot and large language models in general begin to really be like, okay, we want to do this even further. So rather than buy the black box, they're more likely to kind of build their own system. And so with Continue, what we're trying to offer is the open source interface that's decoupled from the rest of the system so that the other components in that system can be modular. And this kind of goes to our business model where those other components will sell. But you as an organization can decide, do you build those, do you buy them from us, or do you buy them from potentially other vendors? And that's where we're trying to go with this space, is similar to what all of you have experienced in data analytics or Jesse experienced in DevOps, right? We want to create an open ecosystem where as developers automate more of their jobs using LLMs, using the reusable components that your platform development team offers, you'll have the opportunity to kind of evolve your job to building the AI software development system, right? So instead of just automating your job with a black box and then now you don't have a job anymore, our hope is a future where software engineers, as they automate their jobs with LLMs more and more, that they kind of are amplified, they're empowered to basically work on the systems that now do the job that they used to do. And so that's what we're aiming for with Continue. Thank you for listening to my talk.